Yo everybody, welcome to our lab video. Our group is made up of Brody, Jack, and Jacob.
Before we get into this lab, it is crucial to understand stoichiometry and a couple other concepts. Stoichiometry is a study of quantitative relationships between reactants and products of a chemical reaction. Stoichiometry follows the law of conservation, which states that no mass is created nor destroyed in a chemical reaction.
In this experiment, we will see what is called precipitate, which is a solid, and a supernane, which is a liquid that rests above the precipitate. Lastly, it is vital to understand what limiting reactants are for this activity. Limiting reactants are reactants that are used up first in a chemical reaction, thus stopping the reaction from going any further. For example, let's say we have 3 kids and 5 shoes to produce, 1 kid for every 2 shoes. In this example, or in this equation, the shoes will run out first, leaving the 3rd kid with only 1 shoe, meaning the shoes are the limiting reactant as they are controlling the reaction.
Now that we understand the basics, let's jump into our chemical equation. We have 2KOH plus CuSO4, which yields to K2SO4 plus CuOH2. The KOH, or potassium hydroxide, appears as a clear liquid similar to water, as it is transparent, and the copper sulfate appears as a bluish-teal clear liquid.
We started by filling each tube with 5 milliliters of copper sulfate. Then we filled each tube from 1 to 8 with an increasing amount of KOH starting with 1 milliliter to 8 milliliter.
Finally, we finished off each tube with the correct amount of distilled water to raise each test tube to a total of 13 milliliters. After letting them sit for a while, you can see some of the precipitates that were forming, which eventually settled to many different heights.
Here are the many heights of the precipitates. It begins with 4 millimeters and raises to 20 millimeters until it starts to level off and stay around 15 to 20 millimeters high. This graph may be an easier way to understand the raise in height and leveling in tubes 5 through 8. As you can see, the trend increases early, but stops and stays in a similar area for the rest of the data.
So what does this data mean? Well, as you can see in tubes 1 through 4, the precipitate height increases. And if you remember from the beginning of the activity, we had 5 milliliters of CuSO4 for each tube and an increasing amount of KOH from tubes 1 through 8. The CuSO4 stays at 5 milliliters through the entire experiment, yet the KOH values change. And since the precipitate height increases, with KOH being the only variable that increases itself, the KOH must be controlling the reaction, or in other words, it is the limiting reactant in tubes 1 through 4. In test tubes 5 through 8, however, there's a flip-flop. At first glance, one would expect the precipitate height to keep increasing in tubes 5 through 8, similar to what happened in 1 through 4, but this is incorrect. In tubes 5 through 8, the precipitate height levels off, even though the KOH is still increasing. The extra milliliters of KOH in tubes 5 through 8 is no longer producing greater results, so it is no longer the limiting reactant. Since the KOH is not controlling the products in 5 through 8, it must mean that the other variable, CuSO4, became the limiting reactant.
Now we had incredible amounts of human error in this experiment to the point where we did 2 separate trials. The first trial on the right has high-ranging values and outliers, whereas our second trial is more specific, so it is more credible and trusting than the failed first trial. We likely drained incorrect amounts of solution to the tubes in the first trial. Thank you all for listening to our presentation.
And thank you Mr. Mitchell for the help, and thanks for watching.